We are going now to see the new geometry setup. This is a fundamental part of the simulations since we are specifying all the boundaries, all the surfaces on which we are going to create our meshing setup and our CFD simulation setup later on. For this particular tutorial, we are gonna have a look at a centrifugal impeller, which is quite particular because there are some periodicity boundary condition as well. So this is the centrifugal impeller as I uploaded to the geometry, and we can actually see this is only a slice of the whole impeller. This is because we want to apply this boundary condition, this rotating periodicity boundary condition, in order to reduce the overall cell numbers. In general, we can say that the water, the flow, gets into the impeller from this side and goes out of the impeller from this other side. At the same time, we keep in mind that we want to define a higher mesh resolution on the internal blade compared to all the other remaining walls. Well, the first thing we have to do is to define the boundaries. So let's start from the inlet. Let's create a new boundary and let's name it inlet. Create. We can now create the outlet boundary conditions. So outlet. We can now move to the two periodicity boundary. One is this one in red, which we can call period 1. And then we have its counterpart, it's behind the pump, and we call period 2. As I said before, in order to define a higher mesh resolution, we have to separate the internal blade from all the remaining walls of the boundary. So we select it and we create the blade boundary. And now we can select all the remaining surfaces and assign them the wall boundary. It is possible to edit the boundary details we have just inserted by clicking on the Manage Boundaries button, and then we can show, hide and delete each of the boundaries we have just inserted, or even we can rename it by double clicking on the name and then modifying the name. I don't want to rename it actually. To move on, we have to define the file units. We have quite a few available. The default value is millimeters, and by clicking on this icon, we can get the information such as the size of the file we uploaded to the system. As we can see, the file units are 125 in X direction. This means the file has been uploaded or defined in millimeters. So the default value is corrected. We can move on and we can define whether the flow is internal. For this case, we only have this option available. And we can now click on Submit to perform all the checks if the geometry has been created and correctly set up.